Let's do one more variance calculation, but this time we're going to do it for a discrete random variable rather than a continuous random variable. All right, so the variance of x is what we're going to calculate, where x is the result of rolling a fair six-sided die. So what this means, fair six-sided die, is that the probability of seeing a 1 is 1/6, the probability of seeing a 2 is 1/6, and so on. Okay, so if we want to calculate variance, we definitely need the expected value of x. So let's calculate that first. The expected value of x is 1/6 times 1 plus 2 plus 3 plus 4 plus 5 plus 6. So in other words, the expected value of x is 3.5. Now, if we want to use our shortcut formula, we will need to use the expected value of x squared. So let's calculate the expected value of x squared. So again, we have 1/6 times, and now this part's going to change because we're doing x squared instead. We have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. All right, calculate those squares, add them up, divide by 6, and we get 91/6. So that means that the variance of x is equal to 91/6 minus 3.5 squared. So that gets us 8.75/3, which is equal to 2.916666 forever. All right, so let's compare this method of calculation, expected value of x squared minus the square of the expected value of x, to the very first calculation that we showed you. We're going to see that it saves space and I think effort, but that is kind of a matter of opinion. So the expected value of x squared minus the square of the expected value is equal to, well, we're going to have 1/6 times, we know that our die can return a 1, so we could have 1 minus the mean squared, and then we'll have the square of 2 minus the mean divided by 6 again, plus 3 minus the mean squared times 1/6 plus 4 minus the mean squared divided by 6 plus 5 minus the mean squared divided by 6 plus 6 minus the mean squared divided by 6. So in other words, this is equal to 1/6 times 2.5 squared times 2 plus 1.5 squared times 2 plus 0.5 squared times 2. So either way that we calculate it, we get the same answer. This is just my preference that I like to calculate this way. Sometimes it makes it a lot easier. Sometimes it's just as much work either way, so it's kind of up to you. But it's useful to have both of these calculations around so that you can figure out which one is easier and then use that one in that particular case.